Thank you. That's great. Thank you all. Just give that. Right. So, okay, this is the high level cause map that, so I have created. Let's say whenever there is a performance issue, right? So if there is a performance issue, so highly, so we divide performance issue is two types. One is query performance, second one is server performance, right? Server wide performance. So server performance can be anything, right? So either it could be a CPU, memory, IO, whatever, so server, the entire server level performance issue. If it is a query performance, right? So we'll have to look for a specific query, right? So let's say, for example, you got a case or you are working on one issue and the application team or user mentioned like there is some slowness, right? So if it is a slowness, so you'll have to understand whether that particular, what does it mean by slowness, right? So either a query slowness or entire query slowness or entire application slowness, like what is the slowness, right? So we divide that into two categories. One is query performance, second one is the overall performance issue that we'll have to start looking at, right? So let's say, for example, if it is a performance issue, then we'll have to check if there is any specific query which is running slow, right? So if slowness is because they're executing query and they started seeing slowness, right? So if that is the case, we'll have to work on a specific query, right? So is it specific query? If it is not a specific query, then we'll have to see the other parts, right? Either configuration issue or any server-wide performance issue or any other issues with respect to the configuration server or any server-wide performance that we will have to start looking at, right? So here we mentioned these are all called server-wide performance issue. Server right? So we'll have to see if there is any specific query slowness, right? So there is no specific query issue, then we'll have to see if there is any configuration issue. So what does it mean by configuration? So configuration can be anything. For example, let's say uh, Tempdb, right? So you have not configured properly. So we will talk in detail, like what does it mean by configurations and all with respect to Tempdb later, right? So for example, understand is not properly set or is not properly configured as per recommendations or some configuration server wide parameters or database wide configurations, right? So we will talk in a bit. So in none of these configurations are properly set, right? So if that is the case, it might leads to a performance issue. Let's say, for example, max degree of parallelism. So max degree of parallelism set to 0 and you have around 32 CPUs or 16 CPUs or even 8 CPUs that matters, right? So it can leads to a performance impact if you don't properly configure max degree of parallelism. Likewise, few other configuration we will talk. Like if any of the configuration issues, then we end up seeing slowness. So if configuration issue, if there is no configuration issue, so here the value should be no. If there is no configuration issue, then we'll have to check if there is any high server, if there is any high CPU, memory, or IO, or any other server-wide bottleneck that we have, right? So we'll have to start looking at server-wide performance issue. If there is a specific query, let's say some stored procedure is running slow, or some job is running slow, executing slow, right? So if we identify a job or stored procedure, then we'll have to start working on that particular stored procedure itself or particular job itself rather than troubleshooting the entire server or all the queries. So we'll troubleshoot a specific job, a specific stored procedure, right? So here, any specific query or process flow, right? So let's say it is a query performance. The process or query or job is slow. Then yes, it is a job specific process is slow. Process with respect to it can be a statement or it can be a job, it can be anything specific thing, right? So specific query or specific job or store procedure, whatever it is. So we know that a specific job is running at around every day at around 5 a.m. and we use it to execute within 1 hour. Now it is taking 5 hours, or now it is taking never completed. So that is where we know the specific job, specific process, right? So then identify the statement or query. So what is the difference between these two? So let's say, for example, you have a stored procedure which has 10 statements, individual statements, right? Or 10 queries within the batch. So each statement can have different executions time, right? So let's say, for example, I have a stored procedure, the overall time is around 10 minutes. In this, the one stored procedure, one statement is taking almost 8 minutes, and remaining all are taking 2 minutes. Then we'll have to troubleshoot that particular the particular statement itself rather than troubleshooting the entire stored procedure. That is what it is. Identify the statement or query. If the statement or query is identified, then we'll have to work on query tuning. That we will talk, right? So that is what the query tuning comes into picture, right? So if the statement is not identified, then we'll have to capture different traces to get the queries, which are slow, right? So this is the high level cause map for the performance. But again, so this is one thing. This is the high level cause map. For example, the health check you identify, let's say, for example, you don't have any specific query slowness and the configuration, there is no issue with the configuration. And you see that some memory issue or CPU issue or storage issue, IO. Any issues which we have at the server wide, it can lead to the performance issue, query performance, right? It would or it can lead to query performance, right? So these are all interlinked with each other. Even if there is any high CPU, high memory, high IO, that is something that we are executing at the SQL Server side and which are cause this spikes, memory, CPU, or IO, right? So that is where we will have to start looking at the query performance again. At this time, so we, based on the metrics, based on the server-wide performance issue, we are capturing some traces and we are getting the queries, which are consuming most of the resources. then again we'll go back to query performance, right? So that is the reason. So all these are important that we will have to work on, right? So this is the high level performance cost map, right? So we will start looking at one by one, and we'll try to explain every area in SQL Server. In today's discussion, so we have a big topic called SQL operating system. SQL operating system, I will cover in maybe next session, because that requires a basic understanding of, so few we are going to discuss. Like, so uh, SQL operating system is a big picture, right? So you'll have to understand the basic configuration. So before even jump into the SQL operating system, or before even jump into further, so you will have to understand the basic configurations, right? So basic configurations that we will have to start looking at, right? So basic configurations we require. What are the basic configurations that we have, and how to look into how that impacts the performance issues, right? So I'll not keep this window open, right? So because this distracts our concentration. So I'll just use this, or I'll use the paint, so that, so I will try to explain here. Okay. So let's say, for example, if there is any performance on the server, right? So what is the first prerequisites, or first thing that we'll have to have, right? So proper, so hardware configurations, right? So we should have a proper hardware configuration. So hardware configuration that we have, right? So that is the hardware and operating system considerations, right? So we'll have to have hardware and operating system considerations. Let's say, for example, number of CPUs. So if you don't have, so if you don't have proper CPU configurations, so what will happen? Your query is running slow, right? So you should have a proper CPU. You should have a proper CPU, right? So these are all hardware configurations. So the divided, the configuration would be hardware and software configurations, right? Database wide configurations, server wide configurations, right? So hardware configurations will have to make sure that we have a proper CPU, proper memory that we have, right? So on the system. So I'm not going much into that, because we should have this, configured. And then memory configuration. So you should have a proper memory configuration on the server, right? If you don't have a proper memory configuration, or if you don't have a proper system CPU configuration, what will happen? So you will end up seeing slowness, right? For example, let's say you have uh, 10 databases. Let's say, for example, you have 10 databases, and then you have only 4 CPUs. Let's say, for example, and you have uh, around 500 or 1 TB database altogether. Let's say, for example, 10 databases, you have 1 TB database altogether. Let's say, for example, and you have only 3 CPUs or 4 CPUs. 4 CPUs. So if you have a 4 CPUs, so whatever workload that we are executing, so it will have to run on only these CPUs that we have. So whatever we perform any executions on the SQL Server, it will end up executing on only these on the CPUs itself, right? So this is the basic unit of execution, right? So whatever we perform, so it will be performing on the CPU, right? So I'm talking Windows CPUs, right? So see, a Windows CPU we have 4 CPUs. Then the workload might be increased. If workload increase, these 4 CPUs might or might not be sufficient, right? So that it can leads to performance degrade because each all these four are so pretty much occupied, right? So with the executions and queries and all, then the other queries will be waiting or CPU will be spiking up, right? So that is the reason you should have a proper CPU configuration based on the workload that we have, based on so the server configurations that we have, right? CPU. Also, you should have a proper memory configured, right? So if you don't have a proper memory configuration, for example, let's say you have 1 TB database again, and you have only 12 gigs of RAM, right? So if you don't have a proper memory configuration, then what you end up seeing, so yeah, you end up saying that there is a memory pressure, right? So we will talk memory in detail, but you don't have a proper memory configuration, then you end up saying that so the memory pressure and memory issues, because this 1 TB database has to be like so you are doing some operations at the SQL Server side, and this data has to be pushed to the memory, right? If that is the case, you don't have sufficient memory. If you don't have sufficient memory, then you end up seeing slowness, right? That is the reason you should have a proper memory configurations on the server, right? So whatever memory you have on the server, let's say for example, you have 100 gigs of memory on the server. So we should have a proper memory configuration at the SQL Server side as well, right? So based on the memory on the server, we can configure memory to the SQL Server. I'll talk memory configuration in a bit later. For SQL Server memory configuration, especially. Okay. So next, the hardware configuration is the disk subsystem. Whatever we perform anything on the SQL Server, it acts as the storage, because the data that we have, right? So the databases that we have, it is resides on the disk, right? This is your disk subsystem or disk drive, I drive, for example. So then your database is resides on this storage. Whenever you try to execute, whenever you execute any query, let's say for example, select query, this will access the storage. Or you are doing some insert, DML operation, insert, update, delete, anything. So this will also write into the storage. So any operation that you perform, so this is the basic that it access the data and read and write into the data disk, right? So if the disk is slow, let's say for example, slowness, there is a slow, and while reading it is slow, writing it is slow, then that is what we call it as a disk bottleneck, disk performance. Read and write are slow, or disk itself is corrupted. What will happen? Disk is corrupted, then your entire database can be corrupted, right? So you should have some other way of recovering the data. That is different story. But if the disk is not properly configured, or if the disk is not optimal, then it can leads to slowness, and also it can leads to a database corruption. So make sure that storage is optimal, right? If how we as a SQL team would make sure that say disk is optimal, right? So we'll have to look at so the SQL Server side. So we'll have to look at the performance of the storage which SQL Server is hosted on. Then from there we will have to suggest that okay, I noticed this is the so disk latency, so we can ask Windows team to work on. So we will talk in detail about the disk configuration, IO bottleneck, right? So here, this is the configuration that we'll have to start looking at. These are the hardware configurations, right? So this is the hardware configurations. It is subsystem. And network also can lead to performance. Let's say, for example, application team complaining that the queries are running slow, right? So this is your network. One sec. Okay. So let's say this is your network. This is your SQL Server and application. So application team, client, your database, network. So your client says that there is a slowness. They're executing query and they receive the result set through network, right? So if the client says that the query is running slow, then not only an issue with the SQL Server, right? It can be an issue with the network latency as well, right? Whatever query which is sending, the same query has to be sent to the network, and network has to take care of sending it to the database, right? So the same way, database is responding with the query result set, and network receives the package and send it to the client. So if the network is slowness, then your queries might be running slow. So that also one of the thing that we will have to check. How we will check, like we can see if the query is what time the application started for executing query, what time DB receives that execution, right? So if possible, we'll have to execute the same query at the SQL Server side, database side, to isolate the issue from the network, right? So this is the high level. We will talk this as well. Like I'll show you that few network performance monitor counters to look at, right? So while talking later, that we will discuss, right? These are all. Next, so server-wide configuration. So trust me, like even if you have a SQL Server installed, and if it is not properly so patched to the latest version or optimal, like so n minus one version, right? So let's say, for example, if it is CU21 is the latest, at least you should have a n minus one CU20, right? So in that case, you would isolate or you would eliminate any of the known bugs or known issues. So recently, or not recently, but sometime back, I worked on one issue, whereas one of the memory clerk, so I will use that word just for your, so just giving an example. So one of the memory clerk is consuming most of the memory. Let's say we have around 500 gigs of memory, and one memory clerk, right? So it's around taking 300 gigs of memory, which is not releasing the memory, right? So then I noticed that this memory clerk, right? So has to release as soon as the query completed its execution. Though the queries are completed its execution, the memory is not releasing. Then we figured out there is a patch or bug applied or bug, there is a KB released by Microsoft which fixes that issue, right? So after enabling that, after installing the KB, the issue was gone, right? So there was no issue with memory utilization and memory leak, right? So that is the reason. So one way we can validate if the server is, server is up to the version or not. But again, right, so this is just a high level that we will have to look into, like whatever queries that you are executing. Let's say, for example, you are working on a production issue, and the application team saying that, like, the query is running slow, or the some issue at the SQL server side. So we cannot keep telling that, like, this is so not properly patched or not. We'll have to have some investigation, and we'll have to look into the data and see whether the issue is something related to, so any performance metrics, or it is a slowness because of some known bug. If it is a known bug or any of the issues, then maybe we can suggest, so the patch, whichever fixes the issue. But you cannot simply, so telling that to apply patch without troubleshooting. No, it doesn't make any sense. So you'll have to start troubleshooting the issue, and based on that, we will provide the recommendations. Right. So this one we'll have to start looking at. Okay. Next one is instant file initialization. Can anyone tell me what is that instant file initialization? What is that instant file initialization? That also can impact the performance.
It's a concept that governs the way SQL Server creates or allocates new files to the disk.
Mm-hmm.
Say, for example, if you want to expand, if you want to say you set up AutoGrow on your database, right?
Mm-hmm.
So if the database is now growing,
Mm-hmm.
how fast or how slow it allocates this increase in the database growth on the disk. This is the IFI is the concept that governs this or allocates this database growth on the disk.
But how is that? So your point is correct and absolutely true. And whenever there is an auto growth or expanding, whatever we perform at the database level, like either it is restoring anything, you can consider creating a database and all. So if you enable that instant file initialization, you said like it would be faster, right? So how is that? Like, what is the difference by enabling and disabling this value? Or disabling as in, like, what if it is not enabled? How that impacts the slowness? So in starting 2022, so this feature, there is a good enhancement as well, like the instant file initialization. The, so anyone are aware, like, what exactly the instant file initialization? Like, say, for example, what will happen if you create a database, or what will happen if you expand the database because of whatever auto growth, or you are expanding it manually, or you are restoring the database. So what happened?
But
Yeah. Yeah.
no, I think it has to do with the way the space in the disk are initialized, right? Like
Mhm.
I don't know how to put it, but it kind of makes it faster instead of writing some initial content in the space in the disk. It kind of make it faster when so if you enable it, it will um it will eliminate all this process of checking and writing the initial value to the disk, and this overall make the process faster. Yeah.
Hmm. Right. You're right. Like, what is that initial writing into? What does it what does it mean?
You tell me, I'm not sure.
Okay, no problem. So here, if I take right. For example, whatever operations that we perform, right? So in the SQL Server side, and okay, let's just get a minute. Now, let's start sharing. Initialization. Let's say, for example, you have this, so we are just creating a database, right? So whenever we create a database, so what will happen? Whatever size that we are creating, let me show you that. So I'm just enabling the traceless to see or print the detailed information into the SQL error log. So I'm just creating a database here, right? So if I create a database, we all know, right? So what I have not specified the size and all because it takes the database size and everything from the model database, right? Model database is a template. So if I just create the database, it creates the database with whatever basic size that we have. And if I take this, right? So you see my screen, right? So if you see that the data instant file initialization db underscore ld, whatever like that we have. And if you see here data file SQL 2016, second, this is pressed, just okay. Hmm. Okay, so if I create any database or create any database that it matters, so what it actually happens, let's say this is your data file. So initially, whatever size that we have, let's say for example, this is 1 gig or whatever size that we have, 1 gig, right? So initially, it creates a 1 gig file. So initially, what you mentioned, like it will write into something, and that is what it is zeroing the file, right? So the entire file will be zeroing initially. Once the file is created, it will be marking as zeroing like entire file. And based on the usage, like based on whatever we are writing, it will start writing on top of this, right? So first it will start zeroing the file, then it will, once it started zeroing, once it is completed zeroing, then it will write into the data file. So there are two operations that we are performing, that SQL engine is performing. One, it is zeroing the file, and once the zeroing is completed, then we would be writing into the data file based on the need, based on the usage. Now you are increasing the file, like auto growth, you have auto growth of 1 gig, whatever it is, and you are increasing the file size. Then this is the growth, right? So 1 GB growth. So even if it is growing 1 gig, then it will be keep writing, I mean, keep zeroing the file itself, right? So after zeroing the file, then you would start writing into the data file. So that will impact the performance of your execution, right? So that will impact the performance of your execution, especially when it is recovering, right? So let's say, for example, database is currently recovering after restart. So even recovery would take longer, or you are restoring a database. Let's say, for example, you are restoring a database from a backup. So even that restore does the same thing in backend. That also can take longer, right? So it takes longer with respect to this feature, right? So it takes longer because it has to, it depends on the database size, it has to zeroing the complete file. Two files, one is data file, log file, right? Whatever data files that we have, everything will be zeroing. Whatever log file that we have, so that also would be zeroing. So instant file initialization up to 2019, this is applicable or effect only for the database file. But there is a big enhancement in starting from 2022. It is applicable for the log file as well. It is applicable for the log file as well, right? So earlier, if you see here, I have enabled this feature. So that is the reason I don't see anywhere the MDF for this. I all see that LDF only because I have enabled the feature. I'll show you after disabling, but I have enabled the feature and I see that LDF file only. And the same thing if I execute in 2022, let's see. This is 22 I have. Let's see. I believe no other, so features needs to be installed, enable, but let's see that here. DBCC enable, created database. Anyway, like the entire system, I have enabled the instant file initialization. So instant file initialization, you no need to, so enable or, but I'll show you that. Don't worry. So
Um,
I,
if
yes.
I have a question, is it is there a way to enable
Yeah,
instant
yeah.
file initialization without
Without,
restarting the server itself?
no, restarting
Is that
without,
possible?
no, it is not possible. So you'll
Yeah,
have to
because
restart. Hmm.
I have some servers that's already in production, but it's not enabled. I want to enable it in one of the server,
Hmm.
but yeah, so yeah, I'd want to avoid a situation where I have to restart the server. So
No. So any changes that you'll have to perform, and if that takes effect, you'll have to restart the SQL instance. There is no other way,
okay.
right? So let me see what is this. Okay, so I'll tell you how to enable this instant file initialization, so that we'll see that why even in 2022 we see that LDF file, like whatever, like so LDF file that we have, LDF file instant file initialization. But let's see. Okay, so how to enable that instant file initialization, right? So we have local security policies. And by the way, so starting from 2016, while installing the SQL Server, right? So during the setup itself, there is an option to enable the instant file initialization. So during the installation itself, you can select the feature so that it will install it will enable this feature for you during the installation itself, right? So, but if you installed a long back, and if you haven't enabled this feature, so maybe we can enable by this changing this, enabling this enable in the local security policies, right? So user rights and assignment. So you'll have to go to the local security policies, right? So you can go to local security policies, or the shortcut is secpol.msc, secpol.msc. Click OK. So it opens the same window, right? Uh, in that local policies, right? So local security settings and local policies and user rights assignment, right? So we have user right assignment, and in this you'll have to check for performance volume maintenance task, right? So this is what the so instant file initialization feature enabled, right? So perform volume maintenance task. So here you will have to enable the SQL Server services, right? You'll have to add the SQL services, and maybe you'll have to restart the SQL instance, right? So here I have three instances added here, right? If I just remove all, right? I just removed that, and I haven't, so restarted the SQL instance, right? So if you remove that, and if I take this, like this is 2019, 2022. Okay. So underscore one. Let's say, for example, if I create this one underscore one. So LDF, whatever LDF that we have. So nothing, we don't see anything for SQL Server MDF. Like whatever we have here, this is the local security policy. So if we'll talk another couple of local security policies, but this is one of the local security policies. Perform volume maintenance task. This will enable the instant file initialization. So if it is not enabled, it is always recommended to enable this feature. So to improve the performance, right? So definitely it will improve the performance, especially while restoring the database or expanding or even auto growth that you have enabled. And if that data file or log file is, data file is growing based on like autogrow settings that we have. So this feature would be helpful. It will improve the performance of your database operations, right? So let's restart the SQL instance here. 2016, let's restart. I have restarted the SQL instance and let's do the same thing here. Drop database. Underscore one. Just dropping the database and let's create DBCC, right? So after restarting, remember whatever trace flags that we enable, like using DBCC trace on, so those trace flags would be removed, right? As soon as you restart the SQL instance, because it is a SQL level that we are enabling, right? If I use this DBCC trace status -1, so it tells that what are the trace flags which are enabled on the server, right? DBCC trace status and DBCC trace on, so it enables the trace flag. DBCC trace off, it disables the trace flag for your information, right? So if you want to see what are trace flags enabled on this computer, on this server, so you can check this, right? So this is the trace flag. Now, if I create, I'll have to enable again because I restarted the SQL instance, right? So I have enabled again. So if I create the database and this is how you will read the error log, right? So normally how you will get to the SQL error log. SQL error log, you can go either RDP to the computer, right, server, and go to the file explorer and see the SQL error log files, or we have something called management SQL error log, and you can use one of these SQL error log files, right? So it is a current SQL error log file. So you can start looking at, or if you want to so increase the number of files, right? So currently by default, it will be total 7 files, 7 error log files. But you might think these files are not sufficient. You can configure and increase the number of files here. You can increase the number of limit. So the maximum limit is 99. So you cannot increase more than 99 files, right? So see here, you can decrease, but you cannot increase more than 99 SQL error log files. If you create that, so the maximum error log files would be 99, right? So 99 files will be created. Or you can use this sp underscore read error log as well. So sp underscore read error log, it reads the error log based on this store procedure that we have, right? So it reads the error log file. If it is 0, this is your current error log file. If it is a 1, sorry, yeah. So if it is 0, it is a current error log file. If it is 1, this is a SQL error log. So if you change it to 2, for example, this will take you to the SQL Server agent error log. If I take this and execute, this is your SQL Server agent error log, right? So SQL Server agent that we see here, that is the SQL Server agent error log here, right? So this is your 0. So you don't have any other options like 3, right? So you don't have anything. Either you have to use that 1 or 2. Here, based on number of files that we have, let's say I have 7 total, right? 0 to 6. So I'm using 6. And I want to read that 6th file from error log, SQL error log. Then I can use this and get the SQL error log file. This is my SQL error log file. Okay, so this is SQL error log, 7 SQL error log file, right? Likewise, you can use. So you can also filter with the string. Let's say I'm just wanted to read only these word string from the SQL error log, whatever SQL error log that I have. So you can use this one to get the data, right? So let's create database, right? The database has been created, and let's see what we get from the logs. Zeroing, right? See here, if you see here, so while creating the database, it says the zeroing completed on E program files, Microsoft SQL or whatever it is. This is the MDF file, data file, right? So it says that, so it is zeroing the file because how did I get this data? Because I have enabled 3004 enable and 3605 trace flag is to write this information into the SQL error log, right? So this will detail information of the instant file initialization or detailed information, and 3605 is to write into the SQL Server error log, right? So because of and because I enable these two trace flags, I see this information stored into the error log, right? So I see here elapsed time is 197 milliseconds, right? So elapsed time is 197 milliseconds to perform this zeroing, right? So this is the total elapsed time. So elapsed time is nothing but total duration of the execution, right? So it took around 197 milliseconds. So this is just an empty database, right? Let's say, for example, you are creating a huge database, right? So it's in hundreds of gigs, right? Even in a terabyte. So if this feature is not enabled, just think, right? Just assume that how long it takes for you to perform this zeroing. So that is the reason. So this is recommended to enable this feature to avoid this zeroing of the database files, especially. So log files. So there is, I think starting from 2022, we have, so instant file initialization enabled for the SQL Server services as well. But let's see. I will restart the SQL Server services for 2022. And you see here only few services are here because this is your 2020 2016 configuration manager. If you have any higher versions, you would not see all the services in the SQL 2016 configuration manager. That is just for your information. If I open this 2022 configuration manager, you will have services for 2016, 2019, and 2022 as well. So I'll just open this 2022. Right? I will restart the SQL service, right? The SQL 2022 is the default, so default instance. So while restarting, Right. So this is done. Like if I create the same thing here, you would see end up seeing the same behavior even in the 2022 as well, right? Drop database and enable this, create database, read, and you would start seeing that 105 milliseconds, whatever it is for the 8 MB data file, right? So this is the log file. So at the same time that you go here, 8 MB data file. So it took around 116 milliseconds to perform, right? So it takes longer, so based on the database size that we have. Now let's enable instant file initialization. So you'll have to enable instant file initialization in the performance volume in the local security policies, which, right, like you'll have to go to perform volume maintenance task. So what you'll have to enable here, you'll have to add your SQL Server service account here, right? So SQL Server service account that you'll have to go to. So now let's say how would I get the SQL Server service account? So one way is using the configuration manager and copy that service account. Second way, like for example, if you connect to the jump server, if this is a jump server or this is a remote server, or even this is your local machine, you don't have access to the computer, the Windows machine, or even it is a jump server. So instead of connecting to the instead of a remote desktop, instead of taking a remote desktop to the server to get the service account, you can execute a T-SQL query to get the service account itself, right? So what is the T-SQL? Select star from sys.dm underscore OS server sys.dm underscore dm underscore server services, right? So it gives what are the services which are running, right? So for this particular instance, it matters. And what is the service account that is running under, right? So here, SQL 22 is running under this service account, whereas SQL Server 2016, this is 22 again, right? So I'm checking here, right? So if you see here, I'm checking down. So what is the service that we are currently connected? What is the instance that we are currently connected? Select star from sys.dm underscore server underscore services. So this DMV gives the service account details from the T-SQL query itself. This is the SQL Server service account for 2016. 2016. Let's enable this. Check, right? This is the SQL 2016 feature. Sorry, 2016 service account. And this is for 2022, right? So if I enable this, right? So these features are just added. These service accounts are just added. But if I create again, like it would not even affect, right? So let's say, for example, one on 2022, whatever. If I go here and execute this, and you still see MDF, MDF, yeah. So you are still zeroing the file, the MDF file, right? So that is what it is, right? So that is the reason we'll have to enable and then restart the SQL instances here, right? So you can just restart whatever different ways that you have to affect the changes, right? And even you can restart from the service SSMS itself, right? So if I just go with restart, you can try restarting. Right. So this feature enable, right? So I'll just drop the database 2022 and even I'll remove this 2060. I'll drop the database here as well, right? So if I go with trace flags again, create a database, right? So we are at least right, so reducing the zeroing of your data file, right? So I told you like until 2019, so we have this ldf file still, I mean, so ldf file is still going for zeroing, right? So we cannot avoid that. So starting from 2022 there is a feature enable, right? So to improve this, let's see that if it is enabled by default or we'll have to look at. I have never tried creating this, but let's see. Let's create and see. Create a database. So LDF file is still taking up. Um, that's fine. So we'll see if there is any other, so additional features that we'll have to enable to, so enable this feature for 2022, right? So, but yeah, so at least this will exclude whatever, so the zeroing to the data file. Right. So that is the instant file initialization. Now, so you have another feature called LPM, lock pages in memory. So can anyone tell like what is this lock pages in memory? So we will talk detail about the memory, and even this will we will discuss in detail in a different session, complete internals and complete different session, and how that works and how that improve or impact the performance, right? Whether it is a additional benefit or not, that we will talk today. But how, what, like we will talk more in detail, like, so why should we enable these log pages in memory? So that and all we will talk in the memory, right? But this is the basic configuration that we all should aware of before even go for performance troubleshooting or any of the performance troubleshooting that we are working on. So can anyone tell me what is this feature? What is that? LPM, lock pages in memory.
I think this is a we are while installing this SQL server, we have given this option lock pages in memory
Hmm.
to until unless it is not releases the memory for OS.
Okay. So, what do you mean by until and unless? Suppose, let's say, for example, if you don't enable this feature itself. So what?
Whenever the Windows OS requires the memory, it releases the
Hmm.
memory. If it is not enabled,
Okay.
when it is enabled, then SQL server doesn't release the memory.
Correct. Correct. That is true. That is the expected one, right? So lock pages in memory, right? So whenever, just I'll just touch base in a high level. So let's see.
But I never use this option while installing.
No.
Please tell us whenever you can.
Yeah, that's fine, right? So while install, it doesn't matter like whether, like, so you can enable this feature after installation,
Yeah, sure.
and during the install during configuration, and after installation you'll have to enable, right? So let's see what does it mean, right? So let's say, for example, this is your computer, this is your server, right? So server, yes. Any questions? Okay. So let's say, for example, this server, you have 100 gigs of RAM. So 100 GB of RAM that you have on the computer. So this 100 gigs here, you have enabled SQL Server around 80 gigs, right? So SQL Server, we have allocated 80 gigs of RAM, like whatever recommendations, like 70 or 80% that we have allocated to the SQL Server. Now, so while growing, right? So SQL Server, so while you just restarted the SQL instance. So if you restart the SQL instance, so then what will happen? It will start increasing the memory based on the usage. And this is the cap that we have, 80 gigs. Now, what will happen if you don't enable this lock pages in memory feature? And let's say, for example, this Windows operating system requires some amount of memory. Let's say, for example, Windows operating system required 40 gigs of RAM, because whatever process that is running and whatever it is, right? You have some other process which is taking more memory, or some other application which is requested more memory or taking more memory, right? So it operate Windows operating system needs 40 gigs to process some operation. Then what will happen? Then SQL Server is the highest consumer. Windows sees that SQL Server is the highest memory consumer. Then SQL Server memory will be trimmed. Trimming is nothing but SQL Server memory will be cut down, right? So it will start trimming the memory, or the memory will start cut down. So instead of that, so we can lock the memory by enabling lock pages in memory, so that the memory which is allocated to the SQL Server cannot be trimmed or would not be cut down, right? So we will talk like how that works later. But for your understanding at this point, if you enable the lock pages in memory, if there is any external memory pressure, right? So because of external memory pressure, the memory would not be trimmed, or the memory would not be so reduced for the SQL Server. So what will happen if the memory is trimmed? So it impacts with the SQL Server performance itself, right? Why Windows operating system is trimming the OS SQL Server memory, right? SQL Server has to manage its own memory, right? So instead of we let Windows to reduce the memory, cut down the memory, so we are setting lock pages in memory so that Windows would not be able to trim the memory, right? So how Windows would not be able to trim the memory, that we will talk later, right? So there is different APIs which comes, so under, like, we will have to, that is internal behavior. If you enable that, it is using a different API called AWE API. We will talk that in the memory areas, right? So it uses that AWE API internally to, so that the memory which is allocated to the SQL Server is not visible to the Windows operating system, right? So that is the reason Windows would not be able to trim the memory. So just a high level to remember. So if you enable the lock pages in memory, the memory which is allocated to the SQL Server would not be trimmed by the Windows operating system by external memory pressures. External memory pressure is nothing but at the Windows level, if there is any memory pressure, the memory would not be trimmed or would not be cut down if you enable lock pages in memory feature, right? So how to enable that lock pages in memory? Again, the same thing that you will have to enable from the local security policies, right? So lock pages in memory, I have enabled for 2016. The same thing that we'll have to disable the SQL Server service account and restart the SQL services, right? So how to check whether the lock pages in memory is enabled or not? Can anyone tell me how you validate? Like someone mentioned, like they have tried, they have enabled, or I believe that I assume that you maybe enable the feature, right? Whoever enabled this feature, or whoever already knew this feature, how to validate whether the lock pages memory is enabled or not? By just checking the security policies, or we'll have to look anything else? So we have, let me see, select star from sys.dm underscore os sysinfo. Let's see if I have this here. So let's start from sys.dm underscore os underscore memory underscore nodes. Okay, this allocated KB. Okay, fine. So you can validate this DMV as well, sys.dm underscore OS memory nodes. If you have this log pages in memory feature enabled, you will see that log pages allocated KB would be more than zero, right? Because this is 2022, I haven't enabled. But if I take the same thing for 2020, 2016, you would see some values here, right? So we will talk what is 0 and 64, but here you see that log pages allocated is some value. So you can see that the log pages are enabled. Otherwise, you can go to the SQL error log, sp underscore read error log, control T for the text result, or control D for the grid format, and I'll just use this control T for the text format, right? So if I go here, so if the SQL service is started, so this information will be printed in the restart SQL services. Whatever services which are so whatever SQL error log created after restart of the SQL services, then this information will be printed into the SQL Server error log. So if you see here, using log pages in memory manager, right? So from the SQL error log, you can identify whether log pages memory enabled or not. If the log pages memory is not enabled, what you will see in the SQL error log? See here, this is what you see using conventional memory model, right? So this is the default memory model that we have. We will talk that in the memory architecture and all, but this is the default memory model that we have. If you don't enable the log pages in memory, by default, it is using conventional memory. So whereas Windows can reduce the memory for SQL Server, right? So we don't want Windows to reduce the memory. So I will use the log pages in memory. How to enable the log pages in memory? I'll have to come here and we'll have to enable log pages in memory, the service account that you'll have to add, right? So this is,
Sorry, I have a question.
yes.
Say for example, so you said when log pages in memory is not enabled, then Windows, if any Windows process need a lot of memory, it can trim down the memory that a SQL Server is using, right? So the question is, what if you set up the memory allocation? Say you set up the minimum memory allocation, right? And you did not enable log pages in memory. Will the operating system still be able to reduce the amount of memory SQL Server is using? Say, for example, you set up the minimum allocation. Say you have an 8 GB memory and you set up the minimum allocation to 7, maximum to 7.5, for example, and then log pages in memory is not enabled. Will the operating system be able to reduce SQL Server memory below the minimum allocation you've set up on your SQL Server?
Yeah, it is very good point. We will discuss that. So that is where that we will have that, so min server, max server memory. Yeah, that is very valid and good point, right? So if you don't enable that log pages in memory, but I will talk okay, wait, went. Okay, so let's go with whatever you mentioned, right? So min server memory and max server memory. first let's understand what is that. Like we'll come to this point because you touched that. Let's talk this max server and min server memory a bit. So let's say, for example, you have a min server memory. That is very valid point, right? So people who are not understand, who has not understand like what was the question. Let's say, for example, uh, I will talk, right? So let's understand that min server memory. So this is your min server memory. This is your max server memory. So let's say min server memory that I have configured is, for example, 1 gig. And the max server memory that I have configured is 80 gigs, for example. So what will happen during the startup? The SQL Server will start with the minimum amount of memory. So can anyone tell me what is this min server memory for? I think Casey already mentioned, right? So something like, so anyone tell me what is this minimum min server memory for? And when you start the SQL service, so how that works, like whether it takes this minimum memory that we configured, or what exactly it happens, like
I,
whenever we have.
I think minimum memory is reserved for Windows OS.
Minimum memories for Windows OS, what does it mean?
From one minimum 1 MB means 1 GB means
Hmm.
from 1 GB it will start. 1 GB is reserved for Windows.
1 GB. Okay, so let's say, for example, you have configured 10 gigs. Let's take this value as 10 gigs. Like I have around 100 gigs of the system memory, and max memory I have configured 80 gigs, and min memory I configured 10 gigs, right? So I'm just starting the SQL services. I'm just starting, right? So it's not been running. I'm just starting the SQL services. So what will happen? Like how much memory it takes to start? You mean that it takes 10 gigs to start?
Actually, it can take in between the 10 to
10 to 80?
that's what I am thinking.
I think 4 to 10.
4 to 10.
Hmm.
How is that calculation? 4?
I think 4 GB is required for Windows OS. It's
No,
reserved
no,
for
no. My
Windows.
point is, so let's say Windows OS that you have allocated, you have left around 20 gigs for Windows operating system. So remaining 80, I out of 100 gigs is the Windows. I have a RAM on the server. So in out of this 100 gigs, 20 gigs I have left for, I have just, left for only the Windows operating system, right? Remaining 80 gigs I have configured for the SQL service. Now my point is, the SQL Server, we have two options. One is min server memory, second one is max server memory. Let's say, for example, go to the properties of the SQL and memory. We have two features, right? One is min server memory, second one is max server memory. What is the big value, right? So min server memory is 0 and max server memory is the random use value, right? Default value. Now the question is, if I start the SQL instance, what would happen? Right? In this case, in my scenario, the minimum memory is 10 gigs that I have allocated to the SQL Server. The maximum is 80 gigs. Now, so how much minimum memory it takes? Like what is the minimum? What is the memory it takes to start the SQL services? Whether it takes this or it takes like whatever value that we have.
Don't know. Please.
What is that?
Don't know.
Okay. Anyone?
I think it will take the minimum that your operating system needs to start, right?
10 gigs?
Less than 10 gigs. Less than.
What
Probably
level? Uh-huh.
probably around
Yes.
I think that it will take what you said if it is 10 gig, which is why recommendation is to leave it at 0 so that it will take what it requires.
Okay. Okay. Let's say, for example, yeah, I left it 0 and I have not configured. Let's say I have configured 10 gigs. and I have around 80 gigs allocated, and I have overall 100 gigs to the Windows operating system. Let's take an example which is configured, right? So 10 gigs. So how the SQL behaves like while SQL service is started. And your point is valid, right? So you will have to like, so maybe I explain a little, right? So the reason that Microsoft left it 0, why? Like suppose if you left this value 0, right? So if you have not configured anything, so what will happen to the SQL server? What is the value it takes? So the same behavior should happen even if you configure this value something, right? So okay, just to explain, right? So SQL Server, whatever value. Casey, you wanna add something, or you mentioned something earlier, right?
No, my question was regarding log pages in memory and when you set up.
No,
So when you
that I
configure,
understand. Like your question, I understand.
okay,
The point
okay,
you mentioned something, right? If you use that max server memory and min server memory as the same, whether the memory would be trimmed or not. So that
yes,
question
yes.
and this is interlinked, right? So that's what I thought of asking, like whether you have anything like, so what is the min server memory meant to be here?
No, you can use any value to explain.
Okay, fine. So, okay, so this means server memory will come to the point. But if you restart the SQL instance, so what it with respect to whatever bin server memory that configured, with respect to whatever bin server memory value that we have, SQL service will start with the minimum memory that it can grow. It can start with. Let's say, for example, I have so configured means our memory as 10 gigs. But during the startup, it only needs 500 MB to start the SQL services because it has to load some system databases, system pages, and boot file and boot page and all. So I just need only 500 MB to start the SQL services. That's it. It will start with that. So it will start with that memory. And we know the SQL Server is a dynamic memory allocation, right? What does it mean by dynamic memory allocation? So as soon as it starts with 500 MB, it starts growing this memory utilization. So it will start growing, right? So what is the max it can grow? The maximum value that we have here. Let's say, for example, 80 gigs. So 80 gigs is the max that is capped. This is the ceiling, right? So 80 gigs is the max. If you haven't enabled the log pages in memory, and let's say, for example, there is a Windows memory pressure because Windows needs 40 gigs. And I told you it start trimming the memory. Then it will cut down the memory. Up to what point it reduce? It reduce up to the minimum memory that we have, right? So it cannot reduce the SQL memory below this point, right? So this is the reason that we configure min server memory, especially if you are not using log pages in memory model. So the reason that we configure the min server memory is if there is any memory pressure, external memory pressure, so then the memory will start trimming and releasing the memory to the operating system. Till what point it releases the memory? Till the memory that we configured to min server memory, right? So this is the purpose that we configure min server memory. So if you don't configure the min server memory, then it takes the minimum memory, which can be like either like 128 MB or something. If you don't configure that min server memory, and if you don't enable the log pages in memory model, by default it is a conventional memory model. If it is a conventional memory model, this behavior is default, right? So now the question, so is it clear, the min server memory and max server memory?
Yes, yes. Thank you.
Cool. So now the question was, what if you set that min server memory and max server memory almost same? Let's say, for example, it is 80 gigs and 80 gigs. So if you set this 80 gigs and 80 gigs, so the behavior would be same. Like you haven't enabled that max server memory, lock pages in memory, and you are using conventional memory itself, right? And you haven't, so let's say, for example, you have not, you have configured this min server memory and max server memory at the same time. So again, like the memory would not be trimmed because I mentioned this point, right? So if whatever min server memory enable, SQL would not trim the memory below this point, right? So even if you don't enable this log pages in memory, even if you set that min server and max server at the same value, then definitely the memory would not be trimmed. But this is not recommended. I mean, I wouldn't say that it is not recommended. So I have seen that people are using this, still using that, like whatever min and max memory as the same. But let's say, for example, if there is any, you started the SQL instance, and let's say, for example, the memory that we can commit is, let's say, for example, the max server memory and min server memory is configured 80 gigs. 80 gigs and 80 gigs, right? So whether whatever SQL server we have allocated to the max server memory, would SQL server really take that memory? Let's say, for example, I have a 10 gigs of system, 10 gigs of memory on the system, right? So if I use this max server memory as 9 gigs, would my SQL service actually take that max server memory, whatever value that we configured? No. So SQL Server is again a dynamic memory allocation, while it will understand, so what is the max SQL Server can utilize, right? So based on this value, the max will be configured, right? So what is the, what I mean, I'll show you that. Let's say, for example, I have this service. Let's say, for example, I have this, whatever value, like, let's say I have 12 gigs, right? So I have 12 gigs, I'm just going to enable. So if I enable this 12 gigs, whatever memory that I have, and whether SQL Server can consume or can, so use this 12 gigs, let's say max server and min server memory, I have 12 gigs. Now, what will happen? SQL Server is dynamically adjust that maximum it can commit. So based on the memory that I have on the server, right? So based on the memory that I have on the server, it will dynamically adjust. So what does it mean? I will just show you that. No. So I'll just show you DBCC memory status. So don't worry what we are executing. I will show you. Just wanted to show you the maximum memory which SQL Server can commit. So that value I wanted to show. So how you will understand that what is the memory SQL Server can commit? This is your value. Target committed and total committed. So these two are the things that you will have to check, like whether SQL Server, what is the SQL Server memory is max committed, right? So if you see here, max can be 4.3 gigs, 4.3. And the current, whatever current value it is committed is 1.4 gigs, right? So 3 decimal, right? So the 3 decimal value like 1.4 gigs, which is currently committed. The target is 4.3. Whatever memory that we have enabled, this is 2016 only, whatever memory that we have enabled, the SQL Server dynamically calculates what is the max it can grow. So now if you enable this max server memory and min server memory, both are same values, right? So SQL Server, let's say, for example, max server memory is 12, min server memory is 12 gigs. Now SQL Server dynamically adjusts that maximum it can commit. Let's say, for example, 8 gigs. Now max memory will be 8. So then min memory would be 12. Let's say, for example, because this min memory cannot be shown anywhere, right? So as soon as it reaches this, and this will be calculated. So that is the reason we don't let we are not configuring this. Instead of that, we will let SQL Server to decide. So what is the max that it can grow? What is the so minimum that we have to calculate. So the minimum is based on the log pages in memory model. Like if you enable the log pages in memory model, SQL Server internally takes care of the adjustment of this, right? So adjustment as in, like as soon as it reaches the max limit, whatever configuration, let's say for example, the target is 4.3 gigs. The SQL Server can grow only that point. You cannot grow more than that. What is the target? So let's say target is 4.3. Then this is the target. And the lock, this memory is locked. Then it will not go below this value if you enable the lock pages in memory model. But if you don't enable, if you enable this, if you don't enable the lock pages in memory model and you enable that min server and max server memory, these values cannot be adjusted dynamically, right? So what does it mean? 12 gigs you enable for min memory, it cannot be adjusted dynamically. But if you enable the lock pages in memory, the minimum will be adjusted based on the max memory value that we have, right? So that is the reason. Personally, I feel that it is not correct, but I have seen people are still using that max server memory and min server memory is the same. That also can be configured. So that will also not remove the memory, but we will have to make sure that there is no, there is a dedicated, this is a dedicated SQL machine or whatever, like, you'll have to take care of. But instead of using this min server memory and max server memory as same, so we suggest to go with lock pages in memory, because the dynamic adjustment would not be possible if you enable or hard code this min server and max server memory values. So max server memory doesn't matter, right? If you hard code this min server memory, then that is where, like, you will start that memory would not be adjusted dynamically, right? To answer that point in a high level, like we can still enable this min server max server memory at the same point, but I don't think that is so optimal or recommended, right? Did I answer this question? The min server, did you guys are with me? Like, you understand the behavior of min server and max server? So the common misconception
Yes.
would be like, min server memory, if you configure whatever value and it takes that. And the second common misconception, whatever max memory that we allocated to the SQL Server has to utilize that, right? So in both are misconception. Whatever the min server memory, SQL Server will start with the minimum memory it is required. So with respect to whatever min server memory that we configure. Second thing, whatever max memory, right? So even if you allocate 80%, 90%, SQL can utilize. That is the expected to utilize. But what is the actual memory SQL Server can utilize based on the memory that is available and based on the memory that it can take? That is what it is. We'll have to start looking at target server and current target committed and current committed value to understand what is the memory SQL Server can commit. This is your max memory, max server memory, and this is your current memory configuration. That is the reason, even if you leave the system with this default value, whatever, like default value, SQL service would be able to start and you would be able to perform operation. If I take the scenes here, DBCC memory status, this is my local machine, this is the hypervisor. Like I haven't enabled anything. I just leave that configurations default values, right? 0 and whatever, like highest in petabyte, whatever value that we have. Let's say I have, so task manager and performance, I have around, let's see what is the memory that I have on the system. Around 7.6 gigs available, or total, whatever, like, so I have total memory, right? So if you see here, the target committed is around 5.8 gigs, right? So the current committed is 802 gigs, 802 MB, right? 800 MB. So these are the configurations. that it takes care, right? So totals are committed is based on what is the max memory, what is the memory that I have on the system, what is the max it can be calculated. Let's say, for example, if I just restart, let's see what are the services that is running. SQL Server, SQL 2019. I'll stop this. I'll stop the SQL agent as well, like whatever. And what is the memory that I have on the system now? The same thing. Let's see. I close this. Whatever, like forward. If I close around 8 gigs, let's see if I execute again. See, this target is increased. So based on the memory available, so this will be adjusted dynamically, right? If you don't set properly. So if you set the memory with whatever value, so this is the max, this is the cap that we are setting, right? So then the memory would be adjusted accordingly, right? So let's say, for example, we will talk that memory definitely in detail for your understanding now. The current committed and target committed and current committed, we'll have to start looking into for memory related performance troubleshooting, but we will talk that later, right? So that is the log pages in memory that we will have to enable to make sure that, so the memory which is allocated to the SQL Server would not be released or would not be trimmed. So Tempdb configuration, so definitely we will have to look into, but there are enhancements in even 2019, 2017, even 2022 with respect to Tempdb, right? So definitely we will have to make sure that Tempdb is optimal, because Tempdb is a global database, right? Every operation that we perform, every user, every database that we have on the system would be using the Tempdb for one or other operations, right? Either let's say you are creating some temporary operations or temporary result set. So anything you perform, so at the database, even user database level, it uses the Tempdb for some internal operations to be performed. For example, you are doing rebuild index. So even re-indexing uses the Tempdb. So a CheckDB or even CheckDB uses the Tempdb to store the intermediate results that we are having. And you are using a snapshot isolation level. So we will talk isolation level later, but you are using snapshot isolation level. So that versioning will be stored in the Tempdb. So you are using ADR, right? So accelerated database recovery, starting from 2019 we have. So that also uses the Tempdb to store the versioning information. You are creating some internal, like you are creating some, for example, temporary tables, right? To load the data, user data, that also uses the Tempdb. So you'll have to have a proper Tempdb configuration, especially the Tempdb is stored in the disk, and the disk performance should be very good and optimal if it is a Tempdb files, because every operation it is trying to access the Tempdb. So uh, the storage should be optimal with respect to Tempdb, right? So that is the reason. So we should have a proper Tempdb and dedicated disk for Tempdb, so in SQL Server, right? Trace flags that improve the performance of your execution, but these trace flags, majority of these trace flags are fixed in later versions of SQL Server. Starting from 2016, these trace flags are by default, right? So, but yeah, just worth noting, like 3118 and 3117, I see that still even 2019. So I noticed that few of the servers are still utilizing, few of the customers or few of the users are still using these trace flags to like, as a best practice or as a so practice that they follow, right? So what are these? Now 3118. So whenever you create a table, right? So whenever we create a table, by default, SQL Server allocate a mixed extent. So extent is nothing but a 8 KB pages of 8 pages, right? So 8 KB, 8 pages, total 64 KB, right? So 8 pages is grouped together is called an extent, right? So whenever we create a table, the entire extent, like if it is a uniform extent, there are two types of extent. One is uniform, another one is mixed extent. You might already know it, right? Uniform extent is all complete extent is allocated for a specific table, right? So that all 8 pages will be used for this particular table, right? So what if it is a small table which fits within a single or within a 2 pages, right? Let's say I have allocated this complete extent to this particular table, and I have allocated only 2 pages in this extent. The remaining 6 pages will be wasted, right? So the remaining 6 pages will be wasted. Like let's say you have another table created with the same small amount of data, and another uniform extent created. Then that again it allocates only 2 pages. The remaining pages will be wasted, right? So to avoid that, SQL Server database engine, what it used to do, so instead of allocating the complete extent to the table, so we'll allocate a mixed extent. So let's say, for example, I have 8 pages. Each page can be allocated to individual table, right? This one table 1, this one table 2. Likewise, each page can be allocated to different extent, different pages within the extent. So that if a table is only utilize these 2 pages, that's fine. So remaining 6 will be for different tables, can be utilized for different tables, right? But so we have seen some so performance issues while allocating this mixed extent, because it has to identify whichever extent is free. So it has to scan that PFS, it has to scan that SGAM, right? So shared global allocation, right? So there are some performance issues while accessing these system metadata pages, right? To avoid that, so enable this feature will allocate only the mixed extents, so that it will avoid any of the system metadata contention, right? So but Microsoft identified, so enabling this so enabling this feature, that is what allocating mixed extent, caused some performance issues based on some thorough testing and all. So they have enabled this, they have released this trace flag. It removes that mixed extent feature. So Microsoft detected that removing mixed extent, allocating uniform extent, improved performance, so that they have included in the SQL Server 2016 and above, the database engine itself, that it is included. Second one is auto growth, right? So whenever a data file is growing, you have two files with respect to either Tempdb or user database, whatever it is, you have 2 files. So whenever you perform any operation that uses the file, right? So so one after another, right? Whatever files that we use, it uses the files, right? MDF and NDF. So let's say, for example, this file has reached 90%, and this is just a 20%, right? Especially if it is a Tempdb, right? So it is 20%, this is 90%. Then whatever workload that we are performing, it will keep writing, keep load, keep so pushing into this data file. So because you have already 90% completed, so nothing would be running on this, and you will have this 20% completed. So every operation workload will be trying to access this file. So it is kind of overwhelming as in individual files. To avoid that, so Microsoft recommended to use 1117 trace flag so that the auto growth would be equally so auto growth uh, for if even if one file is full, auto growth enabling this trace flag will grow all the other files as well with the same amount of size that we have allocated to the individual files. But again, this also feature is not needed for starting from 2016. It is default enabled in the database engine. Right? These are the two that will still I still see that people are using. Third one is query optimizer fixes. Okay, so query optimizer fixes, right? So this feature, I think even this is also not needed now, but still worth of enabling or testing, right? So like earlier versions that we use it to see that query timeout, the optimizer timeout, right? So if those optimizer timeouts, then by enabling this feature, this trace flag would fix if there are any optimizer bugs that Microsoft has, right? So that are there in the code. So this by enabling this, and we can enable the optimizer fixes. Like if there are any bugs or if there are any issues with the optimizer, so this trace flag would fix those things, right? So this is what knowing these details, right? So either enabling or disabling, that is a different thing. That at least worth knowing these trace flags that we have, that we used. Still, you can enable this optimizer fixes. So this can be enabled either at the query level or even at the so the instance level by startup parameters or even DBCC trace on. Okay. So now max memory configuration that we already talked. So what is this parallelism? Let's talk, right? So whatever queries that we are executing, right? So whatever queries that we are executing, so that can run on multiple CPUs, right? So to improve the performance, let's take an example. We are going for a house construction. So if you are going for house construction, right? So one person constructed the house in 10 days, right? So one person constructed the house in 10 days. Suppose, let's say if there are two people engaged to construct the house, they can finish the work in 10 days, 5 days. Okay. If they properly work together, right? So 5 days that they can complete the whole task or complete the construction of the house. The same thing, if it is 3 people, then 10 days divided by 3. Like if it is 4, 10 days divided by 4. So if you have high number of people engaged or high number of workers engaged, then the amount of time it takes to complete would be reduced. So if you have a parallelism, and it is not a bad thing. So ideally, if it is working fine, then it is a good feature, right? Because we are letting SQL Server to perform the operation parallelly so that the query would be running faster. But let's take the same scenario. One person completes the work in 10 days. Now, two persons involved and one person is doing the work. So ideal expectation is 5 days. One person is doing the work and second person, uh, he went on a leave or going for some vacation, right? Whatever reason, like, or he's not feeling well, or he or she, whatever. So it is not feeling well, right? So like this work is pending. If this work is pending, this one worker one, or so the first person work is depending on the second person. If it is a house construction, so one has to wait for other, or one so uh, work has to be waited for another to complete, right? The same thing, if this is slow, then the entire work will be slowed down. right? So that is where you will start seeing issue with the parallelism, right? So if parallelism is good, if everything is working as expected. Parallelism is bad if one of the thread or one of the session is not, one of the thread is not or lagging behind, right? One of the thread is waiting for longer, one of the thread is lagging behind, or one of the thread is blocked or performance, whatever it is. And if you have this kind of thing, then is parallelism would impact the performance of the execution, that we will have to look into. But we will talk query performance later, like parallelism comes under, like, how to deal with parallelism and how to look into the parallel threads and all. Right? So this is the parallelism. And one thing I haven't mentioned is the cost threshold for parallelism. Right? If I take this, go to the properties of that and advanced, right? So cost threshold for parallelism and max degree of parallelism. These two are interlinked with each other. So what does it mean? So you're executing a query and the query cost, the individual operator cost is less than 5, then it will not go for parallel execution. So cost threshold for parallelism value is defined. So when the query go for parallel execution, if it is set to whatever value, and if the query is more than the value that we defined here, then it is going for parallel execution, the parallel threads, right? So this value is depending with each other. So cost threshold is not depending on the max degree of parallelism, but max degree of parallelism is depending definitely on the cost of the query or cost threshold for parallelism value that we have. Starting from 2016, we have Microsoft enable this max degree of parallelism at the database level as well, right? If you go right click on the database, go to the options, and if you go down, where is that? Target query. Oh, sorry, this is 2014, right? So if I go here, 2016 and above, options, you have a max degree of parallelism set to 0, right? So you can set individual for the secondary as well. Like if it is especially always on, so that helps, right? So max degree of parallelism you can enable at the database level on the SQL Server starting from 2016, right? So I'll just mention like one feature, like then we'll wind up for today, right? We'll wrap up for today. Okay, so this is the max memory and parallelism that we have. So optimizer for ad hoc workload. So what this is also important. Let's say for example you have a huge ad hoc queries. Ad hoc query is nothing but, so you're executing one time and not, so you're executing a different query again, you're executing different queries altogether. Like it is not a parameterized query. Let's say select star from table where id equal to 100. That is not a parameterized query. It is an ad hoc query, right? So select star from table where name equal to ABC, right? That is also an ad hoc query. So if you are executing high ad hoc workload, then what will happen? You will end up saying that plan cache is bloating, right? Plan cache is keep writing into the plan cache. The plans, everything is keep writing into the plan cache. That can leads to the memory pressure, internal memory pressure within the SQL Server, right? Or that can leads to the performance issues, because if you increase the plan cache size, so you are basically indirectly you are reducing the data cache size or buffer pool size, right? So that is the reason if you have a huge ad hoc workload, it is optimal to enable optimizer for ad hoc workload. So what will happen? I'll just high level, I'll mention here. Okay. So let's say, for example, you have a SQL Server and you are executing some workload. some ad hoc workload, and it will create a it will store in the plan cache. Plan cache, right? So you have a huge amount, a huge plans, right? Because you are storing every plan. You are executing a select query. Example: select start from table where ID equal to 100, and this creates a plan, and this creates a plan and store it in the memory plan cache, and you are executing another query, and that also will store everything in the memory. So maybe this same query plan might be used or might not be reutilized, right? So if the same query execute, this plan will be used. If the same query is not executed, then the plan will not be reused. So in that case, what will happen? The plan cache is keep increasing because you have a very high workload, ad hoc workload, and that can leads to high plan cache, uh, increase in the plan cache size. Now, what will happen if you enable that optimizer for ad hoc workload? So whenever you execute a query, the query optimizer compile the query and it creates a stub of the query. I mean, it stores the stub of this particular plan. So what does it mean by stub? It is just a piece of information. It can be in a 1 byte or 2 bytes of information. It will be stored in the memory, stating that there is an ad hoc query. That plan handle that information it will store. It will not store the complete execution plan in the memory. Now, if optimizer thinks that or optimizer detects the same query executed again, then this stub will be converted into the plan. So optimizer uses this plan, right? So two things. One, if you enable that optimizer for ad hoc workload, the entire plan will not be cached. As soon as you execute, it will not be cached. So it will instead, it will create a stub or it will store as a stub, right? So stub is nothing but just a small entry point. So it will store that stub information into the memory, that is your plan cache. And if the same query executed, this stub is converted into a plan so that the plan will be stored into the memory. This stub will be converted so that the stub will not be existed. It will be converted into a plan and the plan will be stored into the memory for later uses because it identifies that the plan is reused or the same query is re-executed. So this will be converted as plan and plan will be utilized. Plan will be stored in the memory, right? So that is the reason if you have a high optimizer for high ad hoc workload, I will show you that how to identify ad hoc workload details and all. So this is just a configuration that we'll have to look into, right? So this is the high ad hoc workload. This configuration option controls how SQL Server cache execution plan of ad hoc. It initially stores the stub of the plan and cache the plan during next execution of the same query, right? So this is what you'd have to. And database wide configurations, these are all like we never use, right? So who enable this auto shrink, who enable this auto close, right? So these are the best practices. If you enable, avoid all these things, right? So you'll have to have proper VLF's configuration as well for the transaction log file. So you will not configure VLF, but at least a proper auto growth and initial size to maintain this VLF count and VLF size. These are all base, right? Basic. Compatibility level starting from 2014, Microsoft has released some changes in the cardinality estimation, right? So some database optimizer changes, right? So that improve the performance, that can degrade the performance based on the workload that we have. We will talk that cardinality estimation during the query performance, right? So this is what it is, right? Unnecessary monitoring. This is just wanted to highlight. If you have any of the unnecessary tracing enabled, let's say, for example, extended events, profiler, or any auditing with respect to database or instance level auditing, or anything unnecessary, it can lead to the performance impact, right? So make sure that if you have any thing keep running, so you will have to make sure that which are turned off or see what data we are capturing, especially if you're capturing the execution plans. that can impact the performance, because it has to scan the plan cache, it has to read the data in the memory and all, and it can lead to the performance problem. So that is what you will have to make sure, that you are not running any unnecessary traces on the server, right? So I'll stop here. So any questions?
So the optimize for ad hoc workload, is that really a permanent solution, or fixing the query itself?
So
So
let's say, for example, you have a high or hundreds of ad hoc queries, right? So you might or might not be able to convert them into a stored procedure. But if you could convert, that is well and good. But if you cannot convert that into a stored procedure, this is one way of, mitigating that, so plan cache for ad hoc workload issue. But we will talk that in the memory area. But here, if you are to answer your question, definitely, if you could fix that fix that query. If it is one or two queries, definitely, right? So you can convert that into a stored procedure. But let's say you have hundreds of queries, ad hoc queries executing, and you might not be able to convert them into a stored procedure, or you cannot, or developers cannot convert them into a parameterized query. If that is the case, maybe you can use optimizer for ad hoc workload to at least reduce the plan cache size. But yeah, so query level, we'll have to look into if there is any ways that we can convert that into a parameterized stored procedure. That is the better option.
so
Hmm.
so there is this query that is running, right? So each time it runs, it's taking, so it's running with a different parameters each time, right? It's the same query, just that it's running with different parameters each time. So SQL on its own sees it that each time it's running is something different. So it keeps creating a new plan for each time the
No,
query runs,
no, it
right?
will
So
not create,
because of,
right? No, so if it is a different, I mean, you're talking about the parameterized query, or you're talking about ad hoc query? If
so
it is
yeah,
a
so
parameterized, and even if you are changing the parameters, that will take at the runtime. So it will not create a different plan. It will use it the same plan. That is where we notice that parameter sniffing problems.
So SQL is supposed to see it as a parameterized query, but is seeing it as an ad hoc query, right? So so the point I'm trying to make is that the query is the same, right? And the query is running, say, in a minute, it's running like say every minute is running like 10 or 15 times in a minute, right? So so each time it's running, SQL is creating a new plan for each time the query runs. So because of that, in a day, the query will create multiple plans, just like you said, bloating the plan cache for SQL, right? So for that reason, we are having this memory pressure issue, right? So now I've enabled optimize for ad hoc query, but I'm thinking about going back to developers to see how we can fix the query further. So that's why I ask, with this enabling optimize for ad hoc, is it a permanent solution, or
This
or
definitely, this is not permanent solution, right? So this is just a configuration that we have to reduce the plan cache size. Suppose until and unless, like, so you don't have any option to convert them into a parameter. But first option, definitely you'll have to go with parameterized queries, right? So you can share that, like you can ask them to convert that into a parameterized query. And if they could convert, that's well and good, right? Let's say, for example, you have thousands of queries. Even if it is one query and keep running with a different parameters, and that is okay, that is easy for them to convert that into a stored procedure, so that or parameterized query, so that the only parameters are different. But let's say you have hundreds of different queries altogether, right? So even if that is the case, and if they cannot convert every other query that are executing on the SQL server, this feature just to enable. But definitely that is where we will have to start working on, right? So the recommended is to use or parameterized query, so that so the query would be, so the plan would be reutilized. Definitely.
So if they wrap the query into a store procedure, then it will continue. It will just run with one plan. Is that correct? So in that case, we won't have this issue of having a lot of query plan bloating the memory cache.
Correct. That is true. Two plans. One is ad hoc plans. Another one is you can consider that parameterized plans. So if these two are the two memory areas which you'll have to look into. I mean, just a high level. I will show you, and I'll wrap up for today. Maybe it's late for few folks. sys.dm underscore. So I'll start from sys.dm underscore voice memory class where type like percentage cache stored, right? So if I take that example, so you have two things. So these two that you'll have to look into. So object CP, whereas you have a high, I would say like, so stored procedure or parameterized queries, where this value that you'll be calculating. If you see that SQL CP value is high, that is where the ad hoc workload queries and plans are high. So that is where you'll have to start looking into either converting the plan or converting the query into parameterized or enabling this feature. So we have another feature called force parameterization at the database level. So we have something called force parameterization that also we will talk when we talk about the query performance and all. So parameterization, by default, it will be a simple. So we have something called force parameterization. These are all like at the database level configuration to see like if we can optimize or you can, so convert that into a parameterized query or optimize the ad hoc workload what we are executing, right? Even if you enable this force parameterization, certain queries, not every query ad hoc query will be converted, but certain queries will be converted as parameterized queries. But again, like these are all additional overhead on the database side and that we are enabling. The better way that if you see that SQL CP is high, then we'll have to start, so ad hoc workload would be high. Then we can ask application team to either convert the queries. If you notice that any specific query which is running with a different values, then we can ask them to convert that into a store procedure. That is the better option.
Okay, thank you.
So any questions? So I am also late. I'll have to rush to the office. So if you have any questions, we can talk. Otherwise, we'll disconnect for today. And then we'll connect next week. No questions? All good? Okay, cool. Thank you. I'll stop recording.